Okay, so this is one of our last notes. We got a few more actually, but
Can't see it, Mr. Crouch.
Oh yeah, okay, sorry. I'll do that. Okay, so this is going to be, we've been learning about geology of Alaska. So we're going to kind of take some notes on how Alaska was formed. A lot of people probably don't know how it was formed. It's kind of a really unique place. Like we know how it has all these, animals and mountains and so on. And the reason it's like that is because of how it formed. And so let's check that out. Okay, so formation of Alaska, the main way to understand it is to understand that Alaska was just a piece of crust or piece of lithosphere that was added to the North American continent. It wasn't originally there. So a small piece was there. I'll show you a picture in a minute. So it wasn't originally part of North America, the North American continent. It was just kind of added on to North America over time as the plates moved apart. And if we were going to look at one of those plates, I think it's right here. Yeah. So here you have the plates here, the Pacific plate, and the Alaska's on the North American plate. But at one time, it was a lot smaller. So it'd probably be the size of, probably be this. All this would be gone. Like that. It's probably that big. This extra part here wasn't here, and even probably could go here. There was just probably a little piece up here that was originally on North America. Everything else was just dragged in over time and smashed together to form Alaska. And so and they call those sections of land that were added, they call them terrains. It's down here. And Alaska's made up of, I have 4 listed here, and I'll move these in a minute, but there's actually lots. And these are the main ones that form. And it's important to remember, Alaska was formed as converging plates interacting. So 2 plates came together and did certain things that happens in subduction zones. And the 2 plates that were interacting are the Pacific and North American plate. We could go back and look at these really quick. So this Pacific plate right here, and this North American, this big plate here. And if you remember, this is oceanic crust, and then this is continental. And it set up this perfect thing where subduction could happen, and because of that subduction, a lot of different things happened to form Alaska. Okay, let's go back here. So the way Alaska was formed, though, was subduction, like I'm saying. So subduction is where one, oceanic, OP, oceanic plate, goes underneath a continental plate, kind of like this, right? And as that happens, something called accretion takes place as those plates are coming together. Okay? And accretion is just this deposit of additional layers of rock as plates collide. That happens all the time. Okay, so this usually happens. We haven't studied this in oceanography. We do, but there's the continent. It actually has a section right on the end called the continental margin. And at the end of that continental margin is where subduction occurs or where mountains form. And a lot of times the continental margin is even in the water. So you can't even see it. You don't really know where the continent is. And even part of Alaska's continental crust as well. It's not all oceanic. Okay. But due to subduction and accretion, I want to show you a picture here in a minute. But volcanism as well. And we'll talk about how that happens. But hot spots like Hawaii, where magma comes up through the plate and and forms a volcano over time, and that can get then crushed as well as the crust is recycled. Okay? And also we have diverging plate boundaries as well, because we have some plates, right, that form that mid-ocean ridge or rise in the middle of the ocean, and they're pushing across a certain way, right? And seafloor spreading plays a part in this as well. Okay, but the main parts that are causing this are subduction, accretion, and volcanism. Okay, if we looked at this, where's that picture I had? Okay, so it kind of, I can show you this accretion idea. Is it? No. Right now. No. Oh, here it is right here. So this is terrain accretion right here. And you don't have a picture of this, but you can see here's the Pacific plate, right? Here's the North American plate. And these little different colored areas, these are all accretions that happen as subduction occurs at a plate. So this little spot right here, let me go back. Maybe I can't draw on it. I guess it doesn't matter anyway because you can't see it. But so what happens here, you can see this North American craton. That's the original part of the plate where it would be. But then you have this YT. It's a Yukon Tanana plate or terrain. And then you have this APW. I forget the name of that one. There's Prince William something. And then Y is the Yucatan. And it doesn't even show our Rangalia one. But these, as over time, as that plate has gone under, it's pushed these sediments it's carrying and rocks it's carrying, and it unloads it to the Pacific plate and adds on to it. So Alaska's kind of grown over time. It used to be very, very small, but over time, as that plate, those plates have interacted, then new terrains have been added from different places as well. Okay, and you can kind of see. What's that?
What angle is
This would be the side. So this is the plate coming in.
on which side though?
What do you mean which side?
Which side of Alaska is from?
This would be the bottom, the Y, the Yucatan, and then PWC, Prince William and Chugach terrains, and then
I know that, but I
APW.
didn't feel like which side of Alaska.
All of it. This is where the subduction happens.
It looks the exact same.
I don't know what you mean.
It's all in a perfect 4 layers that looks nothing like Alaska.
It actually does. It's just doing it's a general diagram, but we'll kind of talk about. We'll come back to it. Okay. But yeah, you can see the kind of the names of them. So if we go back, here's my notes. Here, okay. So, but subduction, accretion, and volcanism are really the main way Alaska is formed. Okay. The first terrain that came in is something called the Yukon Tanana. About 300 million years ago, it got pushed into North America. Okay. And what happens? These plates are spreading out, right? And islands form, right? So, like in say the Pacific plate, it has some volcanism that happens, and a hot spot forms a volcano. Well, as that plate moves across into the other one, it takes these islands and things that form and smashes them into that plate it's interacting with. And those terrains, wherever they formed, then get transferred through accretion to the old plate. Okay? So Yukon Tanana, the first one, formed the Brooks Range. So when those accretions were deposited, it also caused folding to happen as well. And there's also some volcanoes that formed from one plate going underneath the other as well. So, but formed from the Brooks Range. What's really interesting about the Brooks Range that you can find marine fossils, way up in the mountain. So that's kind of where they got some of these ideas. Is they take rock samples and they see marine sediments and they say, well, how can a marine sediment get in a mountain? And this is one of their theories of how it happened. So that's the first one. The next major one is the Stekhina terrain, or accretion, and that formed the Alaska Range, and that includes Denali. So Denali is in this one. And that's actually a former volcanic arc. So kind of like the Aleutian Islands. So when the Yukon Tanana formed, there's still subduction happening, and just like today, the Aleutian Islands are formed as volcanoes arise because of subduction. The same thing happened a long time ago with the Stekhine and formed these volcanic islands, and then as the plate kept moving forward, those plates then get pushed onto land and accreted, whatever those islands are made up of. And that depends on how the volcanoes form and those kind of things. So, and they look at these terrains. So you can look at Alaska, which is really unique. Most places are not like this. If you go to, Iowa and look at the crust that makes up Iowa, it's all the same. It's all the same crust, formed at the same time. Alaska, the crust, or the surface of Alaska, is all different because it's been dragged in. Okay, so, but that formed Denali and all those mountain ranges, the Alaska Rockies, they call them, and but it was a former volcanic arc. And then Rangalia is the one that we know. So Mount Wrangell, Mount Drum, Mount Sanford, that was formed, and kind of the Chugach Mountains as well. What's really interesting as well is that they originated on the equator. So all the land that makes up the Wrangell Mountains and all that was originally on the equator at one time. And they can find fossils, and they look at the makeup of the crust there, what kind of rocks they find, whether metamorphic, igneous, or sedimentary, and then they can find the origin by lots of different ways. We kind of learned about that in the first base camp, how they do that. So that's Rangalia. That's a pretty big one. We'll go back and look at these in the map in a minute. And then the Aleutian Islands is another one, and that's kind of what we see today, right? So we go from, depending on whether you believe it's that old or not, that really isn't the point. So if it took a long time, that's fine. If it didn't take a long time, maybe it happened really fast. Who knows? That's not really the point. The point is they formed in certain layers. The first was the Yukon-Tanana, then there was the Stikina, and then there's the Rangalia, and the last one's Aleutians. And actually, Aleutians isn't actually the last one. But let me just share here. I just thought of something. There's actually another one in here between the Yukon-Tanana and the Stikina. It's the Seward. So, and Seward's kind of flat terrain. That's formed a little different way. But there is this other one in there, Seward. There's lots of more of these. These are just the major ones, okay? And these, I tended to give you the ones that relate to mountains, okay? And so most places you see, they don't have as many mountains as Alaska does. Alaska's a vast area, but we have so many mountains compared to other places. Usually you have a mountain chain. You don't have a whole bunch of different mountain chains. We actually have 4 or 5 different mountain chains in the same place. And that's because of what's happening. One plate is knocking into the other, subduction's happening, and it's accreting all these different terrains as it happens. Okay, so we're almost done here. And, yeah. So the Aleutian Islands are volcanic mountains. I just want to show you something on this map, though. It's pretty important. I want you to see. So if we look at this right here, this map, this plate map, there's something really unique right here in this place on the map. Let's see if I can get orange or something. Right here. Move it. Maybe here. Let's see if I can get orange. Okay. Maybe actually green. Okay. So this spot right here, if I even clear the things here to make it easier. So you see this spot right here? It's a really unique place. Because right there at that plate, you got one plate going underneath the other, but at the same time, there's a transform fault along here. So one is it's going underneath, and it's going side by side at the same time. Okay. So right here, there's a lot of weird terrains because of that. So this is a really, and you know that we're not that far from there. That's kind of where we are. And this could cause, this is one of the things that causes a lot of earthquakes in Alaska, is this fault, or this fault. The fault's formed because that's occurring right there. So you have like faults together. You have a transform fault right beside a convergent fault, or a convergent boundary. So transform fault, transform boundary, and a convergent boundary at the same time. And they're not actually the faults, right? But they form, because the land's sliding by each other, they tend to make the crust crack, and then that forms faults, and then you have earthquakes along there as they get stuck as well. Okay, that's a pretty unique place right here. Not too many places like that in the world. Maybe no other place, actually. I'm not sure, I didn't research that. But here's those terrains. So like I'm saying, so a lot of these times, because subduction's happening and these accretions are getting deposited, it's folding the crust. So you might see some mountains if you're driving down the road to Anchorage. If you look at some of the mountains that are cut, you might see that they're folded. And a lot of times you can see mountains that look like this. Let me see if I can draw it. I'm sure I can, though. Might not be worth it. So like a mountain like that, But you might see it's like folded like this. So like that. And you can see that's from accretions. So the crust gets bent and it doesn't quite break and so on. We have a lot of folded mountains here. Some you can't see it because the cut's not right. You can't really see it. But yeah. So that's that. That's how Alaska formed. Slowly just got pieces pushed together. And I have one last map to show you. Right here. Maybe not. Let me go here and we'll be done. So this is this map, this last map. This kind of shows where they are. Okay? And this is that first one, the red one right there. That formed first. These came along later. It doesn't really show you them. It's not showing you them all. We have the red one, the screen one, and these are all the different ones. They have some peninsular and all that kind of stuff. But that's kind of what it looks like. You can see the pieces here, right, that formed. And make sure you add these to your notebook. Any questions?